What is up? I'm Sergeant Ballistic, but you guys can call me Brian. Thank you for checking out this video. Today I'm going to be taking you guys through the unboxing, assembly, kind of setup, and first prints on this guy. This is the TEVO Tornado 3D printer. But first I want to ask you guys a couple of questions. First of all, how many of you guys actually have a 3D printer right now? If you do, what 3D printer do you have? If you are looking to buy a 3D printer, what price range and features are you guys looking for the most? I just kind of want to get a good idea of what type of printers you guys might want to see. If there are some specific printers you might want me to check out, let me know in the comments below. I'll really appreciate it. So TEVO was kind enough to send this out for the purposes of doing a review of it and featuring it in a few videos. I will be doing a full review of this guy. Of course, it will be completely unbiased, and as all my videos are, they will be very in-depth. I'm going to take you guys through my entire experience with this printer. There is a link in the description where you can pick up this printer if you do decide it is to your liking, and I definitely think it's worth noting that as of the making of this video, TEVO has published the firmware for this printer as well as the majority of the printers they have on the market right now. They are in GPL compliance on this guy, and I'll have a link to the firmware in the description below if you guys want to check it out. So this is of course TEVO's competitor for the Creality CR10 3D printer, and it looks a lot like the CR10 at first glance, but there are quite a few unique features to this printer that might make some people looking at the CR10 reconsider and maybe go for this printer instead. So let's dive into the specs a little bit. It's pretty competitively priced at $339 to $399 depending on where you pick it up and how fast you want to actually receive it. It's, as I mentioned, very similar in form factor, construction, and specs to the CR10. It's got the 300 by 300 by 400 bed volume. It does have that external control box, a single Z-axis lead screw, but some very noticeable differences. One of the biggest ones is that it has a 110 or 220 volt AC SSR controlled heated bed. The heated bed also features a pretty unique integrated glass bed surface. This also comes with a Titan style Bowden extruder and utilizes TEVO's MKS Gen L V1 board with replaceable stepper drivers, so you can actually order several of their printers from their website with upgraded stepper drivers like the TMC 2100. So pause on those specs if you want to see any of them in more detail. I'll also have links, of course, as I mentioned in the description, but let's go back and take you guys through the unboxing and build and setup and first prints on this guy. Getting this guy out of the box, I was very pleased with how well it was packaged. It features laser cut closed cell foam, which secured everything really well. There were no loose parts in the box, nothing came damaged. Digging into the box, it of course comes with physical documentation to help you get started putting the printer together. Of course, a US power cable, a USB cable, an extra PTFE tube, a non-beveled bed scraper. Everything was really well labeled. All the small parts came in 5 different parts bags. And it does come with a few extra parts like an extra nozzle and an extra thermistor cable. It has a full-size SD card. On that SD card, you'll find a Slick3R config file, which is kind of nice if you like that slicer. A Repair Host setup file. I recommend downloading the newest version straight from the Repair Host website. There's also Spool Holder, G-code, and STL files on the SD card. There is a 2020 test cube, G-code file, the TEVO Bed Test file, a PDF version of the manual, and their XYZ test G-code. It of course comes with the ZX gantry. This is the vertical portion of the printer, the control box. Then it also has the Y gantry, which is the horizontal portion of the printer, and that's it. It is worth noting that this doesn't come with a spool holder or any sample filaments, so that's something that if you're picking this up, you want to, plan ahead for. Buy some filaments. Any kind of standard brand of PLA will work pretty well. I've got some links in the description of some of the filaments I really like that you guys can pick up. And in terms of a spool holder, using the filament box and sticking a pin through it has worked in a pinch for me. So one of the first things I definitely recommend you print is some type of spool holder. All right, getting into the build, this is advertised as being 95% complete, and I'd say that's in the ballpark. 90 to 95% of it is already done. The instructions are pretty good and straightforward. You assemble the ZX gantry to the Y gantry. This mostly uses some cap head screws which go into threaded holes in the extrusion, along with some reinforcement plates that utilize screws and hammerhead T-nuts. So one thing that wasn't in the instructions was the fact that I had to manually install the heated bed to the carriage. Not sure why that wasn't in there, but it's really straightforward. It's just screw, then bed, then spring, then the carriage, and then finally you use the leveling nuts at the end to secure each of the four corners together. Finally, they have you go through some last things like tightening the belts, making sure everything is tightened down really well, adjusting the eccentric nuts on the rollers to make sure that the carriages are all moving very smoothly. It did already come with some grease pre-applied to the single lead screw, which was kind of nice to see. I think it took me probably about 25 minutes. I think I could have gotten done in under 15 minutes if I wasn't filming and moving the camera around as well. I think even a novice can get this put together in less than 45 minutes, which is really great. It's gonna help you get started printing really fast. Also have to say I'm pretty impressed with the quality of all the parts. It feels really solid after it's gotten together, very similar to the CR10 in most printers that utilize this aluminum 2020 and 2040 extrusion. It's built really solid. All the constituent components are pretty good. Getting all the electronics hooked up from the printer to the control box is very straightforward as well. All of the leads and cable harnesses are all labeled really well, and they're keyed so you can't put them in backwards. I did notice that both the heated bed and the control box have stickers on them, QC stickers, noting that they are the 110 volt versions. This is important to note. Other printers you can pick up either the EU or European or American version and just switch the voltage to the correct voltage on the power supply. You can't do that with this one. These are specifically matched up. I did go ahead and open up my control box to make sure that the PSU was switched to the correct supply, and bravo, it was. I don't know why you wouldn't expect that. But I also took a peek inside of there and saw the SSR and make sure it was hooked up correctly. It was hooked up all very securely in terms of all the cables. And then I also took a look at that MKS Gen L board, and I'm really happy that this features external stepper drivers so that I can swap those out. I've been meaning to want to, check out something like the TMC 2100s, and this might be a really good opportunity for me to do so. I was somewhat disappointed to see that there was no strain relief on the leads coming from the bed cable into the control box. That is a concern on most printers. As the printer moves back and forth rapidly, some strain can get put on those solder joints and connectors. They can come off and end up shorting, and that's where a lot of the incidents in terms of fire come from with a lot of the printers. I definitely recommend you print out one of these, which is a strain relief for that wire. I'll talk about it more in detail when I get into the prints that I did. Cable management, I didn't really do much. I zip tied a couple of the cables together where I thought it made sense for them, just so that they're kind of not hanging around all that loose. I did notice that the leads seem a little bit shorter than the ones that came on the CR10, which I'll talk about a little bit down the road. All right, now moving on to setup. After I got everything hooked up and powered on, I did the typical test I typically do for pretty much all my printers. That's moving the X, Y, Z, and extruder via the control box, making sure that they moved in the correct direction and that the end stops worked, and all of them did. The extruder heated up as well. Run the XYZ G-code file that they have on there, and what that does is move all the axes back and forth at different rates and speeds. And what that showed me was that I had the control box way too far away from the printer. I had it about where I typically keep the CR10, and it ended up pulling that control box back towards the printer. So that's one thing to note. Make sure you send the Z axis all the way up to the top and the X axis all the way over to the left, and kind of go back and forth on the Y, and just make sure you have enough slack in the leads and have the control box at an appropriate distance. You don't want it kind of pulling that. Moving on to the bed, I heated it up, and man, that SSR makes such a difference. 110 volts can heat this thing up so much faster than the 12 volts on something like a CR10. It does have this thermal pad on the bottom of the heated bed, which probably helps it heat up faster as well, and then hold on to that heat throughout the print. Now moving on to bed leveling, it levels pretty much exactly the same as all of the 3D printers that are like this. You want to make sure that your ZX axis right here is pretty level. After you've tensioned this wheel, just kind of put something between the frame and this bar on this side, do the same on the other side to make sure that they're level. After doing that, you want to go around and level all 4 screws while the nozzle is in the respective corner. And this is where I've noticed the most annoying thing about this. As I mentioned, I had to attach the heated bed to the Y carriage, and in doing so, I noticed that there was nothing that attached the screws to the actual heated bed, which means that when you get to a certain level of tension, you turn the knob and the screw turns along with it. And so that ends up meaning that you have to use an Allen key to hold the screw in place while you tighten the knob, which makes things just overly finicky and annoying. It's hard to make sure you're not pressing down on the bed while you're doing that, so you have to kind of like move the Allen key away, check the distance between the nozzle and the bed, tighten it or loosen it more. And I just wish they would have included something in order to secure it to there. Again, it wasn't in the instructions of how to put this together, so there actually are 4 extra T-nuts that came with this that fit these screws. Maybe those are supposed to go on there, but I don't know because there weren't any instructions. Yeah, I just wish they would have had that sorted from the factory and had that in the instructions, but it should be easy for me to overcome. All right, filament loading. Again, very simple and pretty similar to loading up any other Bowden style extruder. There's a lever on here which will release tension from the idler to the gear. This has the Titan style extruder, which has a knob on here that allows you to feed the filament through the Bowden tube once you have it fed in enough. And I really like this. I've actually done this to several of my other printers, like my Tron XY X1. I designed and put a knob on it, as well as my CR10. So it's pretty cool that they include that. When you don't have that you end up doing is sometimes you're pushing the filament through and you can kind of kink the filament in one direction or another. You can actually break it, or worse, have it become weak and then it breaks off in the tube, and that's absolutely horrible. You can absolutely ruin prints that way. So glad to see they have that on their stock. In terms of the interface, pretty similar to all the other kind of rotary dial style Marlin interfaces that most people are used to. It's a little bit different than the CR10 in terms of where certain specific things are, but most things are in logical places, and it's easy to dial stuff in, find your prints, and get going. All right, now getting into the first prints. The first print I did was off the SD card, and that was this TEVO Bed Test. It actually comes with one on the bed from the factory, and then I printed this guy. I decided to go with green. This is actually filaments from Repcord that I picked up at Earth, and it's a nice little transparent, and I thought it would go kind of well with the copper, maybe green for the money, gold for the honey type color scheme. But yeah, the bed test turned out pretty well. I did notice it started to lift in a couple places near the edge. I was surprised it adhered to the glass without any adhesive pretty well just out of the box. Moving on to other prints, I did notice that I had a lot more trouble with those sticking, especially anything that was tall and skinny, like this tool holder that I printed. It just had a lot more trouble adhering given its height versus the amounts that was on the bed. So I ended up using the trusty glue stick for most of these prints. Interestingly enough, older TEVO Tornadoes used to come with a Build-Tack like material on the bed already from the factory, and then some came with an extra one. I guess TEVO has done away with that in favor of the glass bed. But yeah, other than some minor bed adhesion problems, I didn't have any problems getting prints started. Except for this. This is the filament holder that comes on the SD card. One thing worth noticing is that this does have a pretty high infill density, so it will use quite a bit of filaments. So just be ready for that. Don't use any samples when you're printing this. You might run out of filaments, but it's pretty sturdy, you know, which makes sense, so it can hold a full load. I'm not sure what happened, but it's starting to under extrude and then eventually it jammed and stopped printing. I didn't have that problem with any of the other prints, so I don't know if it was the G code, perhaps the retraction was too high or something like that, but I might print this out again. But I had a whole bunch of these spare spool holders sitting around, so that's what I've been using this whole time now. All right, getting away from the SD card prints, I decided to print a few other things. I already mentioned the strain relief holder. Highly recommend you do that. It'll just, you know, rest your mind assured that you won't have any problems with strain relief on the heated bed. I'm kind of surprised that TEVO doesn't include one. It's one thing that I've noticed that Creality has started to do on their Ender, and I think their newer, some of their newer CR10s, they already have that strain relief part on there. In fact, I think they are injection molding theirs now. So next up, I went and printed out some of these extruder knobs. They take the extruder nuts and just widen them significantly, as you can see, just so you have a little bit more finer kind of resolution as you're turning them to get, you know, get the leveling adjustment just where you need it. I did this on my CR10. I really liked it, so I found a set that worked with TEVO's leveling screws as well, and we'll be putting those on. Next up, I printed a Benchy. Of course, you have to print a Benchy, or maybe you don't. Maybe people are tired of Benchies, but I think it's a very good benchmark for how well your printer prints. And judging by this one, it prints pretty well. The overhangs in particular are really good, meaning that the cooling on this is fairly adequate for, you know, these type of overhangs and arches. There's no super loose overhangs hanging down or anything like that. The extrusion seems fairly consistent for the most part. I do notice a couple kind of zitty areas, particularly where it seems like layers are starting, so perhaps the prime and or retraction amount isn't dialed in perfectly there. There's a little bit of ringing on it, but no more than I've experienced with any of my $100 to $400 3D printers that I have so far. So really happy with the quality of this. All the small features and round parts look very round as opposed to ovular. The letters on the bottom turned out really well. I like the smooth surface that this glass plate does offer, and I'm really happy with the print quality on this and all the prints. So time will tell how well this printer does in the long run. I will be doing a full review, of course. I will be putting hundreds, if not at least 1,000 hours of prints through this printer and giving you guys you know, detailed breakdown of everything I've been through with it. Overall though, I'm really happy with it so far. It seems to be, you know, built really well. It was pretty easy to put together. I think any beginners looking at this printer shouldn't be daunted in terms of how long or hard it is to construct. I think you can get it together easily in less than 30 minutes. I'm really impressed by having this AC SSR powered bed. With that 110 volts, it heats up so much faster than my CR10 at 12 volts. That's MKS Gen L board with the external stepper drivers, is really exciting for me to see, so I can start testing out different stepper drivers, specifically the TMC 2100s. Really looking forward to that. And yeah, overall, I'm really happy with this guy. Now, I did have that jam, but I printed a lot of prints since then and haven't had any repeats of it, so I'm not sure if it was a G-code file. I did have a little bit of bed adhesion problems, but nothing that wasn't solved with a little bit of glue stick. I was a little perturbed by the leveling screws and how there was no instructions for putting the bed together, but I can't knock it too much for that. This is a really well documented printer. If you have any problems, check out the Facebook groups, leave a comment down below and I can see if I can help you as well. But overall, I'm pretty excited about being able to use this printer for projects. So if you guys have any specific questions about this printer, materials, specific prints or benchmarks you would like me to run through and things like that, please let me know in the comments below. I definitely want to help anybody considering this printer figure out if it's going to be the printer for them or not. And that is it. Thank you guys for watching. Go ahead and give the video a thumbs up if you enjoyed it. Give it a thumbs down if you did not. But remember to leave some feedback in the comments below. Go follow me on social media if you guys like talking about 3D printers. I'm constantly on there talking about 3D printing and would love to have you join the conversation as well. I'm on Twitter, Instagram, and Facebook, and on different videos here on YouTube. You can check out some of my other 3D printer reviews, unboxings, and upgrade videos. Just finished a whole series on upgrading that little guy down below, and I will be upgrading other printers in the future. So thank you guys so much for watching. I will see you in the next one. Peace.